Hi guys, this is Justin from Black Module Studio. Just gonna do another tutorial today for Unity. This time I'm kind of starting almost, it'll probably be in the same series, but it's kind of like a little spin-off or whatever. Basically I want to try and create a voxel terrain, similar to, Minecraft or the slew of other, games out there these days. I'm going to try and do it in Unity. And then as we go along and figure things out, maybe we'll try and do some unique things with it. But this video is going to be probably pretty short. We're just going to be rendering a voxel. If you watched the last video that I put out actually yesterday on deformable mesh, it's actually this video is kind of a baseline to that, but it's going to lead into actual creating voxel terrain. So without further ado, let's go and pop Unity open. This is my tutorial project that I have, so like always we'll go and create a folder for it. We'll say tutorial 4, and actually I'm going to duplicate the scene, so we have tutorial 4 for the scene. We'll open that one up, get rid of the deformable mesh, so just have the camera. Let's go ahead and yeah, we'll just leave that there, whatever, it's good. Okay, so excuse me. Tutorial 4. First off, we're going to create just a quick script that we'll call world gen, and this is going to generate the world for us, which in this case, what is that? Oh, that's the scene folder, wrong thing. Scripts, there we go. World gen. Alright, this is basically just gonna in this tutorial just gonna call our voxel script. So what we'll do is we'll create a voxel. We'll call it voxel, and we'll say voxel equals new voxel, and then we'll say voxel dot start, and you'll see why momentarily. We won't need an update function right now. Okay, now back into Unity, create another C# script, and that will be voxel. And then go back into Sublime Text, and we'll open up voxel right here. First off, this is not going to inherit mono behavior, so delete that right there. I'm not going to need an update function, and this we need to make sure it's public so that we can call it from within world gen. So that should, yep, there we go, no more errors. Now we can actually, before we forget, throw world gen on the camera. You can put it in its own object or whatever, it doesn't really matter right now at this stage. I just need it to be attached to an object so it actually starts up and gets called. Now, let's go and start with voxel. So a lot of this is going to be very familiar. It's, a lot of it's pretty much the same same code from yesterday's tutorial, so if you followed along with that, then yeah, you might be able to skim some of this. If not, follow along and we'll get this going. So first off, we need a mesh, call it mesh, and then we're going to need a material, call it mat, and then we'll need a list of vector 3s. We'll call them points. Actually, that reminds me, since we're using list, we need to use system.collections.generic. Another list of vector 3s, and this is going to be the verts. A list of integers, and that's going to be the triangles, and a list of vector 2, and those will be the UVs. Oh, and then finally, since this is not inheriting from mono behavior, we'll need a game object. Alright. And, actually, we will create float for the size in case we need it later, but that's again, it's the same thing as yesterday. It's basically the radius or the half width of each voxel or cube. Okay, so now in our start function, which is not called automatically, we're having worldgen actually call it. First off, we're going to go and initialize the game object, and then the points list. So add our points. I'm just going to actually copy these over from yesterday's code because it is identical right here. And initialize our verts list. Oop. Tries list. And UVs list. And then our create mesh function. Alright, so our game object that we initialized earlier, object, we're going to add a component to it. We're actually going to add multiple components, if I can spell. So first off, a mesh filter. Copy that over twice, and then we're going to do a mesh renderer, and then we're going to do a mesh collider. Alright, let's go and initialize our material. And do some error checking on it. And set our mesh filter. And some more error checking, of course. Alright, set our mesh. Go to our mesh filter shared mesh, and some more error checking on it. Alright, and then our mesh collider. And some final error checking. Alright. Now that we've got all that error checking in, we just need to clear our mesh to make sure that there's nothing residual left over from, like, if we're going to do any updating on these or whatever. So we do a mesh.clear, and then we will call update mesh, and this is where we're going to actually really build it out. So we'll create a new function here. It's not going to return anything. And a lot of this is going to be similar. I'm going to copy this over and then explain it. This is where we're setting up our verts. Alright, so essentially we have the front, back, left, right, top, and bottom planes. And each one of these planes, which is essentially like a square in 3D space, is made up of 4 different points, which indicates the 4 corners of it. So up here we already made all of the 8 points, but for each individual we have a total of 24 points, because for each 6 faces it takes 4 points, and a lot of these overlap. So just to save a little bit of time, we set up the points list, and so we're using those. So anyways, we're passing point 0, 1, 2, and 3 in for the front plane. That's essentially the top left is 0, and then we go clockwise, so the top right is 1, bottom right is 2, and bottom left is 3. And then in the same fashion, we go through each one of the planes that makes up the voxel, which is essentially, for all intents and purposes, just a cube. So now what we do is, since all we've done right here is we've just basically put a bunch of dots down indicating where each corner is. So what we need to do is we now need to build our triangles list and tell it each individual triangle. So each one of those planes is made up of 2 triangles. So our front plane is we're gonna add what this is. That's that integer. That's basically the index into the verts array. So the first triangle of the front plane is index 0, 1, 2. So essentially it is these 3 points right here, 0, 1, and 2, and then 2, 3, and 0. So it is 2, 3, and then 0. Those 3 right there. And that makes the front plane. And then we go through and we do the same thing for each one of the faces right there. And then what we do is we go into our UVs list, build that out. And so basically what the UVs list is it's a list of all the points for each plane where the texture is mapped to. So essentially our texture is going to be a 2D image, and we want this to map to each one of the planes. So we're telling what corners of the 2D image, the texture, map to which specific points in the basically in the verts list. So for this first one is going to map to the first point right here, which remember we said is the top left. And now how the UV coordinate the UV points work is 0, 0 is the bottom left, and so that would be 0, 0. So the first number represents X, and then the second number represents Y. Y goes up, X goes to the right. So X coordinate of 0 means left, Y coordinate of 1 means top. So that's the top left, which matches up right here. So anyways, we go through this, and we map each of these to their respective points in the verts list. And so now that we have our 3 lists built out, we can go and build the actual voxel. So we're going to say mesh.vertices equals verts.toArray. And essentially, we're using these lists because it makes it a lot easier. We can use the add function just to add these points to it. And so the mesh object has an array of vertices and triangles and UV coordinates and normals and so on and so forth. So that's what we're going to set now. But because we're using lists, we have to use the toArray function to actually turn it into an array. Well, it returns an array. And it's fairly quick, so we're not really losing much performance at all. So now I'll do the same thing for triangles. Oop. And UVs. So mesh.uv equals UVs.toArray. And then, in case we need to go through this function again, we want to make sure that since our verts triangles or verts tries and UVs lists are global, we want to make sure that we clear them. So Just go and do that right now, since we've already used them for everything that we need to. Just kind of zeroes them out. And then now, I'm going to take our mesh collider. We'll create a new mesh collider. And we're going to get our component mesh collider. So just so we have that. And what we need to do is we need to say mesh dot recalculate bounds. No, normals, excuse me. And then mesh dot recalculate bounds. And then we're going to call this recalculate tangents function, which we're going to create momentarily. Then we take our mesh collider and we need to set our shared mesh equal to null. This just basically zeroes it out, and then we're going to actually set it to our mesh so that we make sure it's fully updated, up to date and everything, so it matches the actual image, or sorry, the 3D representation of it. That way the collider is matched up. So now we take our game object dot render dot material and set it equal to mat, and then we're going to call mesh to optimize, which does some stuff in the background to optimize our mesh for Unity. Save that, and now our final function is going to be static void recalculate. I always spell this wrong. Calculate tangents, and we pass in a mesh. Alright, we're going to go and create some arrays in here to hold some of our values. Oh, what am I doing? Those are arrays. There we go. All kinds of typos in here today, sorry about that. Alright. Get some integers we'll use as indexes or indices. I want this to be count also, triangle count. Man, I'm just not doing well typing tonight. Alright, so vector3 array for tan1. I'm gonna go and copy that over and call it tan2. And then we're gonna create a vector4 array because tangent has an XYZ and a W. So we need a vector 4, not a vector 3. Oop. Alright. We'll create a couple longs here. We'll call it I1, I2, and I3. And triangles A plus 0. And say I1, I2, I3, plus 0, plus 1, plus 2. Don't know why I said plus 0, because it's the same thing. Alright, so now we got create 3 vector 3s. They're going to be v1, v2, v3. It's going to be the vertices. Alright, so let me pass 2 and 3 in here. And then again with some vector 2s, we're going to call w1, w2, and w3. Alright. The majority of this for loop is just creating a bunch of variables that we're going to use and do some math on, so. Alright, so essentially we're doing the same thing for the x, y, and the z here. Oh, why did I put equals here? It's supposed to be minuses. Telling you, all these typos tonight. Too far into the video to want to redo it either. Alright. Alright, so essentially, same thing for x, y, and z. The first one is going to be v2 dot whatever x, y, or z minus v1, and then v3 minus v1 for each of these. Now we're going to create some more floats. S1, float, not flat. S1 is going to equal to w2.x minus w1.x. Kind of similar here. Because remember we have our w coordinate. W3. And the same thing, but these are with y's. And then these are going to be T1 and 2 rather than S. Almost done here, so we're going to say float div is equal to S1 multiplied by T2 minus S2 multiplied by T1. Float R is going to be equals to if div equals 0.0f, then set it equal to 0.0f, or set to 1.0f divided by div. And then we'll create vector 3, sdir, new vector 3, t2 multiplied by x1, excuse me, minus t1 multiplied by x2, and that is going to be multiplied by r. And I'm just going to copy this because we're going to do something similar for the y and the z. Oops. Okay. So let's see, these need to be y's, and then z's. If I can click in the right spot. Now for our teeter, it's going to be similar but a little bit different. It's going to be S1. Actually, I'm going to change all these first. With the X, Y, and Z, it's reversed. Instead of 1 then 2, it's 2 then 1. Alright, and then these is going to be S1 and then S2. S1, S2, S1, S2. Alright. Okay, so now we're going to tangent arrays. I1 plus equals sdir. Same thing for 2 and 3. And then similarly, our teeters and our tan2. And then one more for loop, this one much smaller. A is equal to 0, A is less than vertex count, plus A. Say vector 3n is equal to normals, A. Vector 3, we'll call it T is equal to tan1, A. Vector 3 dot ortho normalize ref n and reference T. Then tangents A dot x is equal to T dot x. Do the same thing for y and z. And then we'll set tangents dot w equal to vector 3 dot vector 3 dot cross nt tan2 a less than 0.0 f. Set it to negative 1.0 f. Otherwise, set it to 1.0 f. Whoop, f. And then finally, mesh.tangents equals tangents. Cool. Now, hopefully I'll never have to type that again. Alright, so I'm just going to minimize these real quick. Alright, let's go into Unity, see if we have any errors, see if I missed anything. Alright, so now when we do this, we should see a cube. Alright, there we go. There's our cube. That's creating our voxel. Go ahead and click on it. That's listed as new game object, so we didn't give it a name. If I go like this and hide it, you can see it does have a collider. And that's going to be the basis right there for our voxel terrain engine. So hopefully you guys have enjoyed this. I know if you watched the last video, it's a lot of it's pretty much the same code actually. There was more code in the last one, but there was a couple minor changes, and I just wanted to, kind of get this set up as our baseline for our voxel terrain. So hopefully you've enjoyed this, and if you have any questions, please feel free to throw a comment down there and ask some questions, and give the video a like if you like it. Alright, thanks.